As what we talked about last week, we learned the ellipse, and then today we learned the hyperbola. So let's talk about the ellipse again. As a definition of ellipse, you have two focus, then you call it a foci. The distance from any point on the ellipse to here and to here. This two summation is always a constant value. So you point, go here. This two guy plus together equals to this two together, equals to this two together, equals this. But even your point is going here, this part plus here is still a constant, which is 2a. That means you have an ellipse. You will form an ellipse. For ellipse equation, your center at 0, 0, you have x squared over a squared plus y squared over b squared equals to 1. But if your major direction is in the y direction, which you have the vertical ellipse, then you have y squared over a squared plus x squared over b squared equals to 1. For the hyperbola, the definition of hyperbola is any point on the hyperbola. So for hyperbola, any point on this, that distance minus that distance, or you see this distance minus that distance, is going to be a constant value. 2 here minus 2 here. From here, this two distance difference is a constant value. You still call this guy. This one, you see this is the vertices. This one is also called vertices. So if you still define this as a and negative a, just like this point you call a, this point negative a. If your point going here, you can see from this point to here, this time, the C is the longest one. In ellipse, the A is the longest one. For the hyperbola, the C is the longest one. This part is C, this part is A. So if you have a point on here, this point to this left side focus, this two distance is C plus A. From here to here, it is C minus A. This piece is C minus A. So if you use this two distance difference, it gives you a 2A. C minus C canceled. A minus negative A is plus A, so which is 2A. So you have a hyperbola like this. So you can see that you have a point here, comma, x, comma, y. Now, let's do this. Christina. I'm going to let you go through this formula with me. Okay. Can you tell me the distance from here to here? How do you calculate? This is negative c, comma 0. This is x, y. How do you calculate this part? Go ahead, please. Christina? Can you unmute yourself, Christina? Daniel?
I'm not
Christina,
sure.
okay. Distance formula, you don't remember?
Oh.
This is your x1, this is your x2. You do this minus this, right? Seriously? I put the x1 minus x2 square plus y1 minus y2 square. And then you do this square root. You got it? That is a distance formula, right?
Wait, I thought the distance formula was x2 minus x1.
Doesn't matter. x1 minus x2 squared is same as x2 minus x1 squared, right?
Yeah.
Negative 5 parentheses square equals to 5 square. Yes? Go. This guy to this guy distance is who? X minus
C.
negative c, right?
Yeah.
X minus negative c is x plus c square. This y value is 0, so you y minus 0, right?
Yeah.
That is the distance here. And then you minus this guy, okay? How much is this? How much is this distance? Go.
X minus c.
Yeah, x minus c squared plus y squared, right?
Yeah.
And then do the square root. You understand?
Yeah.
This equals to this constant 2a, okay? And then I'm going to just fix this plus to be minus. You got it? So far, so good?
Oh.
And then you have this. To solve this radical equation, I say it many times. You are not able to solve this one if you do this. That's not going to work at all. Because even though you get rid of this square root, but if you double, you will cause this guy times this guy. That's in trouble. We cannot solve that way. So we will move everything here to the right, just like what we saw for the ellipse, right? Go, Christina. I move this guy to the right. Are you okay with this step?
Then you would square
you
both
do square.
sides.
Yes, go ahead, please.
Yeah. So the left would be x plus c squared plus y squared
Equals?
be 4a squared.
Mm-hmm.
And then you would add 4a.
Double. This times this double. So that is the full 8 times this whole thing, right?
Yeah.
And then plus who?
Plus x minus c squared plus y squared.
Okay. So far, so good?
And then you can
okay, I will call
out
next student. Okay, you watch. Haley, let's go ahead. On the both side, which thing can be cancelled first?
Y squared.
So let's get rid of the y squared. And then let's go ahead. Expand this. This become?
X squared plus 2cx plus c squared.
Plus?
Plus x squared minus 2cx plus c squared.
Who can be cancelled?
C squared.
Who else?
X squared.
So far, so good?
Yes.
Let's keep going. We are going to leave this guy on the right. We are going to move everything else to the left. Go ahead.
So negative 4a squared.
Yes.
Plus 4cx.
Equals?
4a square root.
Like this. Okay? Everybody has 4. Can we get rid of the 4?
Yes.
And then what we do next? We can square both sides again, right?
Yes.
Let's go ahead. Square this one will become this guy square. This guy square is who? Negative square is positive, right?
Yes.
So this guy square become?
A squared.
No, a to the power 4.
Yeah, I mean, sorry.
Okay. And then this 2 double. That is negative 2a squared cx, right?
Yes.
And then plus this guy square become?
CX squared.
C squared x squared. Equals, let's go ahead, do this guy square. And then let's expand this one. Go ahead. This one, after square and also expansion, this become?
X squared minus 2cx plus c squared.
And then plus y squared, right?
Yes.
And then let's do the distribution. Hold on, let me copy. Go ahead, let's do this. Oh, hold on, let me call next student. Valeria, let's go ahead and do the distribution, please.
A squared x squared minus 2a squared cx plus a squared c squared plus a squared y squared.
Okay. Now let's cancel the things which can be canceled. Who can be go? Who can cancel?
2a squared cx.
This one. Okay, yeah, the value are the same, then they are both negative. This can be canceled. Now we are going to move. We will move the c squared x to the right. We will move this constant term to the left. So this become
A to the 4th power minus a squared c squared
equals
plus a squared x squared minus c squared x squared plus a squared y squared.
right. Let's check. This term move to the right. This term move to the left. This guy is copied down. This guy is copied down. So far, so good?
Yes.
Okay. Now, let's keep going. We will have, this has a common factor of a squared. So I will take it out. A to the power 4 become?
A squared.
And then minus?
C squared.
C squared, right? And then we will take the a squared minus c squared parentheses times x squared. So far, so good?
Yes.
X squared is a common factor. You take it out. Now we have to keep in mind about the special thing in hyperbola. For the ellipse, a squared equals to b squared plus c squared. For the hyperbola, c squared equals to a squared plus b squared. For the hyperbola, this part is a. So the hyperbola's vertex or vertices, this two guys' distance is 2a. When you draw the tangent line through this, and you will have, for the hyperbola, you will have an asymptote. This asymptote will cross at these 2 points. When you connect these 2 points, this is your B value. So this is called the major direction. This is called minor direction. And this is A, but this guy is B. C squared equals to A squared plus B squared for hyperbola. But for ellipse, A squared is the longest, which equals B squared plus C squared. And make sure don't confuse these two. If we have C squared as the longest, then A squared, look, C squared equals to A squared plus B squared. Then if I minus A squared, C squared minus A squared will become B squared. If you flip them, it becomes negative B squared. So this guy becomes to negative B squared, right? Make sense, Valeria?
Yes.
And again, this one is also negative B squared, right?
Yes.
Okay. Now, when you have this, you will divide each term by this. This guy divided by itself becomes to 1, right? Yeah.
Yes.
And this guy divided by A squared times negative B squared become?
X squared over A squared.
Yes, X squared divided by A squared. This divided by a negative, this becomes to how much?
Negative Y squared over B squared.
Very good. So this gave us the standard equation for the hyperbola. Let's see here. X squared over A squared minus Y squared over B squared equals to 1. Previously, you have plus, that's ellipse. Right now, you change it to minus. It is a hyperbola. So what you can see here, if you see X squared here, if you do plus, you do Y squared here. If you do 4 squared, and then you do 3 squared. If you equals to 1, it's a beautiful ellipse. But if you change this one, if you make this to be a negative, it immediately change this to the hyperbola. So by just changing this negative to positive, the graph totally changed. It's different thing. One is an ellipse, one is a hyperbola. Okay. Now look at this. Next time when you eat those ice cream cone, you can put the 2 cones like in this vertical angle directions and use a knife to cut it through, but just watch out, don't cut your finger. If you cut with a slant angle like this, you will get a beautiful ellipse, okay? But if you cut exactly horizontal to the base, it's going to be a circle, yeah? If you cut horizontally, it's going to be a circle. But you say, teacher, this looks an ellipse. Well, if you look down, that's going to be a circle. Right? If you look at 3D, it looks like the ellipse. So if you cut horizontally, it's a circle. If you tilt it a little bit, this gives you a beautiful ellipse. When you will have the hyperbola, if you cut perpendicular directions, it's going to give you this hyperbola shape. If you cut perpendicularly, it's going to give you this hyperbola shape. If you cut parallel to this edge direction, if you cut parallel to this edge directions, if you cut parallel to this edge directions, it will give you exactly a beautiful parabola. Okay, that's why both ellipse, parabola, and hyperbola are all called conic sections. These three are the same family, but they are a little bit different. Now, let's work on those questions. Go ahead. Completing your square for your x, for your y. I want you to give me a format as x minus x0 squared over a squared minus y0 squared over b squared equals to 1. Do this by yourself. If you really have no idea of how to do this, unmute yourself. I will do with you together. But if you can, please do by yourself and send me your work. Pretty good, Christina. Very good. Pretty good. Every step is perfect. Ethan, there is a careless mistake. X squared minus 4x. So the parenthesis inside for x, it should be a negative, not a plus. Can you change that mistake, please? Okay, it's not x plus 2. You want to fix that. Very good job, Daniel. We have 3 students send me the correct work. One student have a small tiny characteristic. Who else? Number 1. If I announce your name saying you did correct for number 1, then go ahead and do number 2. Sometimes you might say that the x squared term has a negative in front. Don't be scared. That's normal. Your hyperbola, if it's horizontal, is x squared over a squared minus y squared over b squared equals to 1. But if it's vertical, you have y squared over a squared minus x squared over b squared equals to 1. It depends which direction you go. Thank you, Ethan. Anybody else finish completing square for number 1? You finish number 1, go ahead and do number 2. Sudisha, that's right. Good job. Can you do number 2, please? Vanessa, where is your work for number 1? You need to send me your work, Vanessa, please. Do you need help, Vanessa, for number 1? Daniel, double check your work. Number 2, you have some curious mistake. Daniel, you messed up between x and y. You put the mistake you have is you have a y squared plus 16x. Why you do y squared with 16x? Y squared should be with y. Why you do the x? Fix that careless mistake, Daniel. Ethan, no, your second one is not correct. You have some careless mistake. Because the one part you have a negative 16, the other part is positive 16. That 216 canceled. You shouldn't have a 24 on the right, Ethan. That is wrong. Daniel, your word, I cannot see your y correct. Your parenthesis is y plus who? Y plus who square for number 2, Daniel? Danny.
It's y plus 4 squared.
No, it's not y. Hold on. Oh, yeah. That's right. Okay, you got number 2 correct. Y plus 4, right? Inside. Valerio, that's correct. Keep going. Keep doing. Okay, I do see that the students do have trouble for this thing. Let's do this together. I will call 2 students. If I already check your work, see you are correct, you don't need to unmute yourself. Who want me to help with number 1? Vanessa, let's do number 1. If you finish, tell me your work. Go ahead. How did you do this one?
So all we have to do is complete.
Yeah?
Yeah.
So you put X term together, right?
Yeah. Mhm.
So you put these 2 guys first.
Yes.
And then you will minus 25
Five.
y squared
Twice.
plus 50y.
50.
You can put 214 on the right. So far, so good?
Yep. Mhm.
And then you will
Okay.
take
After-
9 out. Yes?
Yeah.
X
Wait, 9.
squared minus who?
4.
Minus 4x. 4 is 2 by x by 2. Correct?
Mhm.
So you will plus whose square? You will plus 2 square, right?
Yeah.
Okay. And then you will minus 25, you take it out. So you have y squared minus who? 25 times who give you 50?
-2.
Negative 2y, right?
Mhm.
And then 2 by y by 1, yes?
Mhm.
And then plus 1 square, correct?
Yeah.
And then
Equals 2.
look, hold on. This couldn't equal because this is a matching term. This 4 by 9 is 36. But this 36, 9 times 4, 36, you don't have it originally. So you plus this guy, so you should plus another 36.
Okay.
To balance, correct?
Mhm. Yeah.
And then this guy is matching. Negative times negative is positive. So this is that guy. But you minus the 25, so you want to balance. Make sense? Okay, so this become
9 times x minus 2.
26 square. Okay, minus 25 times
y minus 1 20 squared.
equals. Let's do this first. This minus this become 11, right?
Yeah, 11, and then that's 20.
225. Yeah, we should know 225 is who?
15
15 square.
squared. Yeah.
Correct? Yes. So this is a 3 square. This is a 5 square. 3 square over a 15 square. So immediately that means you have a 5 square on the denominator. Yes?
Yeah.
15 square. This is 3 square. 3 square over 15 square. 3 square will cancel. So you have a 5 square on the bottom.
Yeah.
And here you have a 5 square. And this guy you will left with a 3 square on the bottom. Make sense?
Yeah.
Now can you do this one correct quickly by yourself?
Yeah.
Okay. Number 2, any. Let's go ahead, completing the square for number 2. We will take care of the y term and the x term separately, okay?
Okay.
So you have y squared plus 8y. That means 2 times y times 4, right?
Mhm.
And then you will plus which guy square?
X squared.
4 square. So in that way, we can save some steps. Make sense?
Yeah.
Okay. And then we will work on the x term. You have a negative 4. You can take out a negative 4. And parentheses, you have x squared, right?
Mhm.
Negative 4 times who give you a 16?
-4.
Yes, negative 4x. So far, so good?
Yeah.
Okay. And then we will move this 4 to the other side, right? This 4 to the other side. But look at this. This guy is matching here. This guy is matching here. This is something extra we have to balance by put it back, correct?
Yeah.
So we will plus this 4 square so that this equation is equivalent, okay? And then who is this?
Y plus
4 square, right?
yeah.
Minus 4 times, look at this, x squared minus 4 times x means 2 by x by?
-2.
2, yes. And then you will plus this 2 squared, right? And this is 16 plus 4. You can first write down this as it is, but you want to watch out. This is matching this. That guy is here, that guy is here. This one is for you to completing the square. But you don't have this negative 4 times 4. So here you want to balance 4 times 4, correct? You want to balance this thing so that your equation is equivalent. Minus 4 by 4. So far, so good?
Yeah.
And then you have one more step. You have y plus 4 squared minus 4 times. Who is this?
X plus 2
X
squared.
minus 2.
Oh, yeah.
If you remember, this equals to who?
A plus
A
A
squared
squared
plus
AB
2ab
and then plus B.
plus b squared. If I have this minus, then this will become minus, right? Okay. Equals to, this canceled. That is 4. Make sense? And then you will divide it each term by 4. Okay?
Yeah.
You divide it by 4. The right side becomes to 1. And you divide it by 4. First guy divided by 4 is 4. 4 over 4 is 1. That's what our new equation is. Okay? Since you missed the beginning of the class, we are trying to get the hyperbola equation. This is what we learned the last class. That's a plus. But for the hyperbola, after we derive here, it has this minus. And you can verify it by looking at here. If it's plus, definitely it's a beautiful ellipse. But if it's minus, it's definitely a hyperbola by just changing the plus to negative. So far, so good?
Yeah.
Now, I suppose everyone can handle this completion the square for both the x term and the y term. If you haven't mastered this skill, I ask one more time. In this class, is there still any student need help for this? Anybody still need help for this completion of square? This is the beginning part. If they give you an equation, if you did the first part wrong, you will get 0 points for that long question. Because if your first step is wrong, everything that later they ask you, what's the vertices location? You will get wrong. What is the asymptote? It's going to be wrong. What is the lactus rectum? It's going to be wrong. What's the foci location? It's going to be wrong. So make sure, number one step, everyone should master now. I asked the last time, is there still any students need my help for this completion of square? I will not ask the question. I will not offer this help again if you don't ask me. If you don't master this, ask me for help right now. I will not offer further help for this type of question. Let's writing equations by looking at the given conditions. So here, this guy, you notice that they have the foci not in the x-axis, but on the y-axis. It is saying you have the hyperbola vertically. You have the foci vertically, and you have the vertex. You have two vertex. Two vertex is called vertices. One of them is called vertex. It gives you just one, doesn't matter. So that means here is 0, 3. Your vertex at 0, 3. Your foci is symmetric over the center. So it's saying your center is exactly at 0, 0, because this two is symmetric over 0. So your A value is 3. But your C value is 8. C squared minus A squared. That is your B squared. You have your A squared, you have your B squared. You know it's vertical. And you know the center is 0, 0. This is pretty easy. Y squared over. If it's vertical, you want to write down the A squared under the Y squared. A squared is 9. B squared is 55. Did you notice that? Here, A is less than B. You might feel something wrong. You say, A, I remember you told us A is always bigger than B. No, for ellipse, your A is greater than B. For hyperbola, doesn't matter. Then how do you know which one is for A, which one is for B? The positive term is for the major direction. That's for A. The negative direction, that's for B. A greater than B, you don't know. You will analyze based on the given condition. So you can see here, if you see this ellipse, you definitely can see if, because 4 is greater than 3, that means X is the major direction. If you change this 3 to be 5, because this is not a yeah. See here, the 10 and 10, this is 1-to-1 unit. Or I make it a little bit more obvious for you to see. If I change this guy, if I make the Y direction, the bottom one is greater, then it's going to be vertical. If I make this X, I say, okay, if you change to 8, I'm going to beat you by 12. It becomes too horizontal. Okay? That means for ellipse, who is greater, who is the major? But for the hyperbola, it's totally different story. For the full square, for here, this is horizontal. But if you say, I'm going to change this to be 1, which is way more less than 3, I think it's going to be vertical. No, it is still horizontal. This is still a horizontal hyperbola. Okay, this is still a horizontal hyperbola. You see? So for the hyperbola, it depends on which term is positive. That is your major direction. Any questions so far? For number 6, I want you guys try by yourself first. I sent each student the private message about the work you sent to me, so then you can read through, okay? If you say, I don't know how to solve this, can I have some hint, please? If you need any hint, you can ask me. Number 6. You want to draw it. For doing this question correct, you have to draw it. So the center, this one centered at 3, 5. So you roughly first know your center is around 3, 5. And the focus at -1, 5. So you notice that from your center, your focus is going to opposite in the y direction. That means it's vertical. This is the first thing you need to know. From the center, you are going down. So your focus is on the major direction. So this means it's a vertical hyperbola. Correct, Vanessa?
Yes.
And center to focus, the distance is the C, right?
Yes.
From center to focus, that is a C value. So C is 4. Make sense?
Okay. Yeah.
And then the vertex from the center, go to the vertex. That is your A value, correct?
Yeah. Okay.
So you have your C, you have your A, you have your center. You can find your B, you have your equation. If you show me a horizontal one for number 6, you are wrong. Please fix it. You know it's moving. No, wait a moment. Sorry, I messed up. Hold on. You are moving on the horizontal direction. First, you are at 3, 5, right? This is 3, 5. Vanessa, come back with me. You have 3, 5, and then you move to the left. Yes?
So it's
Negative 1, 5.
negative.
Yes. So
Yeah,
this is
okay.
horizontal. Sorry. So the C is full, but it's horizontal. Yeah. The A is 2, it's also horizontal. Okay.
Yeah.
Yeah. Christina get the answer perfectly and very fast. Christina, you want to write down equals to 1 for your last one. And if you don't have equals to 1 to the right, I believe your school teacher will take off your points. The thing we are learning right now for all the Conic sessions will all come back next year for your pre-calculus. If you say, I don't like it, then next year you will suffer one more time. That's right. Daniel. This center is not at 0, 0. You miss the term. You miss the center, Daniel. It is not at 0, 0. Same thing for you, Ethan. You too have exactly the same wrong answer. You have to look at your center. Why you don't take care of your center? Hey, Ethan, the square is outside. You want to get rid of the square and put it outside the parentheses. The square position you put that way is totally wrong. Ethan, you need to have this format, okay? You cannot put a square here. That is totally wrong. You got it, Ethan?
Yeah.
Okay. Next one, number 7. You feel confused about who is conjugate. So for ellipse, we say major, minor. But for hyperbola, we will have a new name. For the hyperbola, this direction, minor direction, is called, there is a new name called conjugate axis. Okay. Conjugate axis means that minor direction. So how do we do number 7? For number 7, you have center here. Stisha, let's do this together. So you have center at -3, 1. Okay? And
Okay.
you see that your focus is moving upward, right?
Yes.
So that means this is in the y direction, right?
Yes.
So you go from center, move upward. That means this value is how much?
3.
C, right?
Yes.
C equals 3. So far, so good.
Yes.
And you also know your center. But this question here is saying end point of the conjugate axis. So if you draw this hyperbola, your hyperbola is like this. This is called the vertices or vertex. And you have this asymptote. You draw this guy through here, which is a rectangular box. And that guy, this guy, is called the end point. The point here and the point here. This is the end point of the conjugate axis. So your center is at -3, 1. Center at -3, 1. This position is -3, 1. And you move to this position, which is -1, 1. So this is -3, 1. And here is -1, 1. This distance is that B value. Does that make sense?
Yes.
So B is +2, okay?
Okay.
So if B is +2, C is +3, you will have A squared as C squared minus B squared, which is 9 minus 4, which is 5. Okay?
Okay.
So you have Y minus center. Your center is this. So you will have Y minus this 1. Some people say Y plus 3. No, this is X. This is Y. Y minus this center 1 square over this A squared. It's in the Y direction, so the A will stand under Y. So this is A squared. And B squared is 2 squared, which is 4. So you have this. I'm going to delete my work. Can you first, you want to draw this, and draw this. If you can draw it visually, you should be able to figure out the correct equation. Give a try. Christina, very good. You did pretty good. Good job, Ethan. Very good. Good job, Daniel. That's correct. Okay. Let's keep going. Number 8. So I don't want to all of a sudden introduce too many new names that make you feel lost. Let's say the hyperbola one more time. If you using ellipse, we say major direction, and that's minor direction. But as long as it's a hyperbola, you have to come up with some new name. The major direction is corresponding to this thing called transverse axis. Transverse axis means the places where the focus pass through. So if you have a hyperbola like this, you call this transverse. You call this transverse. But that is always the conjugate. But if you have a hyperbola horizontal direction, this is called a transverse. This is called transverse. And that is called conjugate. So if you use the major or minor term, transverse means major, conjugate means minor. So if I see a question saying n points of the vertical transverse, it's saying my major axis. They give you these two major axis point. That means this is corresponding to that two location. But here, because it is vertical, so you will redraw it, saying this point is negative 4, 11. But this point is negative 4, 9. After you have this, you will immediately know that this is negative 9, okay? You immediately know that between these two, your x is the same, your y is totally different. The y distance between these 2 points is 11 minus negative 9, which is 20. 20 equals to 2a, so a is 10. 20 equals to a, so a equals to 10. At the same time, this 2 point is the end point in the major direction. If you do the midpoint, it's corresponding to your center. So this 2 center, you will do minus 4 plus negative 4 over 2, still negative 4. 11 minus 9 over 2 is going to be positive 1. 11 minus 9 over 2 is positive 1. So this is your new center. You have this new center. You have your A equals to 10. But you have a new name called eccentricity. Previously, when we introduced ellipse, we will say, oh, because if you have two foci, same location at the center, it's a circle. So C is 0. So E is C over A. So for a circle, eccentricity is 0. But for ellipse, your C is less than A. So ellipse is E less than 1. But for hyperbola, E is C over A, but C is the longest, so E is greater than 1. So for hyperbola, eccentricity is greater than 1. You have this equals C over A. You have A ready. You calculate your C. You finish your C. You calculate your B. You have your A, you have your B, you have the center. You know which major or transverse direction. Go ahead, do your number 8 on your own paper. Yes, both Christina and Ethan got number 8 correct. When you feel confused or have trouble to do this, you draw those points, and then you will be able to get it. This is the high school pace. Immediately when teacher introduce something totally new concept, over a sudden you will be asked to do the application questions. In the class, they only show you the center at 0, 0. Over the quiz or test, you never see those kind of questions before. Or you even see something you never heard of before. I want to talk about the number 9. This guy gives you the center. Endpoint of the conjugate axis is 1, -5. Conjugate axis, that is corresponding to the minor direction. Okay, so you won't see the foci on this conjugate direction. You will see the foci only on the transverse direction, which is a major direction. The difference of the foci radii. Radii means radius. You have 2 center. For hyperbola, you also have 2 center. You have 1 center here, you have 1 center here. Since you have 2 center, they will call it focus. 2 of them is foci. This guy is called a radius. And you have 2 center, so this is one of the radii. This is the second radii. And this 2 radii difference is 26. When we learn at the beginning, the first 10 minutes in this class today, we know that this 2 difference is 2a. So if you see the difference of the foci radii, this is 2a. So this is 2a. A will be exactly 13. So you have your A here. When you have your A, and here is your center. But from this center, you want to see. So we can draw here. From 1, -2 to 1, -5, you are moving vertically. And this is the conjugate. What does this mean? That means this is a horizontal one, because conjugate corresponding to the minor direction, this is shifting upward. So that means this major direction is the x direction. So you will see A is 13. Your A is 13. Centered at here is negative, it's 1, -2. And you have your conjugate axis, which is here. So this is from this -2 to -5. This gives you the B value. The distance of this 2 from center to the endpoints of the conjugate axis. This 2 difference is B value. This is moving in the y direction. And this is the conjugate direction. That's a minor direction. So your B is 3. A is 13. B is 3. Okay? So you will have happy saying, oh, center already know. So x minus 1 squared over a squared. This is horizontal direction. Minus y plus 2 squared over 3 squared equals to 1. That's what's going on. That's number 9. Next, we will take a look at those graphing questions, okay? Let's take a look at those graphing questions here. If your school tests on this part, they will give you question like this. Give you the equation, ask you to completing a square. answer those vertices and point of conjugate axis, eccentricity, foci, and then drawing the graph. So for number 13, can you guys go ahead? Completion square for this one. First, do this guy, completion square, with your x, with your, there's y square only, so you don't worry about do the y. You just do the x, and then you make your right term to be 1. Change that to the standard equation. Let's do it, number 13. If you have the graphing paper, please get your graphing paper ready so that you can draw the hyperbola on your graphing paper. Valerio, you want to make the right side to be 1. You haven't finished yet. You need to do the division as your last step. That's good job, Annie. Annie, after you finish the equation, can you figure out your vertices? Write down your vertices and points of conjugate axis, eccentricity, and foci.
Okay.
Good job, Sudisha. Good job, Daniel. Ethan, that's correct. When you finish all of the equation completion the square, go ahead, answer your question of vertices and points of conjugate axis, eccentricity, foci. That's right, Haley. Valerio, thank you. That's right. So what you find out here, you have this, okay? Yeah, I see all the students get this part correct. And then let's see who answered those following questions. Yes, Daniel, that's right. When you have this guy, you will see this because the term for x is positive. So this is measured in x direction. And based on this 16, so your A is 4. Your center is at 3, 0, because it's horizontal direction. So you will move your A to move the center to the left by A, to the right by A. So 3 plus 4 give you a 7, 7, 0. 3 minus 4, -1, 0. So you have the vertices. Okay, you have these two parts. Endpoints of conjugate axis. Endpoint of conjugate axis means you're drawing a box, and this box is going to be along the asymptote. So in that direction is B. This is called endpoints of conjugate axis. So you will start from the center 3, 1, 3, 0. You're going up by 3. 3, 0, going up by 3, 3, 3, going down by 3, 3, -3. So you have these two pieces. Next one, eccentricity. A is 4, B is 3. C squared is this square plus this square, which is 25, so C is 5. Eccentricity is always C divided by A. C is 5, A is 4, so you have here. Next one is the foci. You have the C is 5, and it's in the major x direction. So from this 3, 0, you move to the right by 5, it becomes 8, 0. You move to the left by 5, it becomes -2, 0. After you have all these important points, you will be ready to draw your curve. Your center is at 3, 0. So I'm going to draw this thing, okay? Let's look for this. Ethan, center is who?
3, 0.
So 3, 0 is this. This is the center, right?
Yeah.
And who is the vertices? What are the vertices?
7, 0, -1, 0.
So this guy go to the right by 4. So this is 7, 0. And this guy go to the left by 4. So this is -1, 0, right?
Yeah.
And the point of this conjugate axis. So you go from the center, go up by 3, go down by 3, right?
Yeah.
Right. So you have this box. After you have this box, you will connect this box full endpoint cross direction. After you have this box ready, you will connect this diagonal direction. In that way, you will have your, this is the asymptote. This is a slant asymptote. And you have that point, you have that point. You will draw this. You want to pass this center, you want to follow this asymptote. You have this guy here, vertices, you want to follow this trend. There you go. You have your beautiful hyperbola. Make sense?
Yeah.
Go here, go here. This is major direction vertices. Go up, go down. This is your endpoint of conjugate axis. You connect this rectangular box, you draw your asymptote. The point here pass, but along this asymptote. That's it. From the center, horizontal direction go to the right, you have one of the focus. You go to the left, you have another focus. So you have two foci. That is your curve. And then your asymptote. For this asymptote, you look at this. This is your B value. This is your A value. So let's do this, Ethan. We want to find the asymptote. The asymptote, you see here, this is your B, this is your A. If we don't worry about these lines first, we only do this part. Let's use the point slope format. Who is this point?
3, 0.
So you will do y minus 0, y minus 0, y minus y1 equals to the slope. This is how much?
3,
This is
5, 4.
4. So this is 3 over 4 times x minus 3. That is this line. Make sense?
Yes.
And still passing same point. This line slope is negative. So you will have a plus minus. That is your asymptote. So you have this guy over here. This is your asymptote. Make sense?
Yeah.
Okay. Any questions so far? Your school might ask you additional question because for ellipse, when we have the foci, through the foci, you can draw this lectus rectum. Will you have also lectus rectum for hyperbola? Yes. Through the foci, you draw the line perpendicular to the major direction. You're crossing with your curve by 2 points. This is called end points of lectus rectum. When you see here, Sudisha, remember for ellipse, what is the lectus rectum length for ellipse? Sudisha? Who knows for the ellipse, what's the lectus rectum length? It's 2b squared over a, right? For ellipse. For hyperbola, you have this guy. That is your hyperbola equation. And you see, note the center is not at 0, 0. So suppose you do this original simple equation. And your x will be c for the focus x value. So your y squared over b squared equals to c squared over a squared minus 1. Yes, Ethan, that's right. When you do c squared over a squared minus 1, so you have c squared minus a squared. C squared minus a squared is b squared. So your y squared will becomes to, again, same formula as what I show you guys in the last class. If you miss last class, you have to watch out the video to make sure you can pick up from there. This guy is that length. That is the lectus rectum length. That is the lectus rectum length. And then if they ask you, you can know. If they don't ask you, you feel happy, don't need to remember. But this is the same formula as the ellipse. Ellipse lectus rectum is the same. But the ellipse definition of A and B is different with hyperbolus A and B. Now, 14. Go ahead, complete square for your x and y by yourself. Put the square positive term in the front. That means put your major in the front. That's pretty good, Daniel. Okay, yeah, you get this one very fast. So again, this question is still the horizontal direction. But you notice that here, this 4. Daniel, you can unmute yourself. You see here, this 4 is way more smaller than this one, okay? So that means it's not like this guy is greater, this minor, it's major. It's 4, but this term is positive, so it is still horizontal direction. Make sense? Look, how do you find the vertices? Which one is the center? For this, who is the center?
-2, -4.
So this is the center. -2. 1, 2, 3, 4, -4. This is the center. And A is how much?
2.
A is 2. So you will go to the left by 2, go to the right by 2. This is our vertices, right?
Yes.
Okay. And then your B is how much?
Root 21.
Square root of 21. So you will go up by square root 21, go down by square root 21. So let's roughly estimate how much is square root of 21. Square root 21, right?
Yes.
Yeah, because this is a radical. This is a irrational. So we won't be able to know how much, but we will approx. 21 is less than 25. It's greater than 16. Make sense?
Yes.
So that means this is 4 square, this is a 5 square. Okay, look at this distance. This guy plus 5, this guy plus 4. So I think it's more closer to this direction. Yeah,
Yes.
that's why I try 4.6 to approach. Yeah, I don't think they allow you to use calculator. So let's do a 4.6 square to see if this guy is close enough to this number. Okay, let's do it. So far, so good.
Yes.
21.16. So my estimation of 4.6 is pretty good, right? Yeah. So I can use 4.6 to approach. Make sense?
Yes.
So I will go up from this point. I will go 1, 2, 3, 4. 4.6. So my B is going to stop over here. Make sense?
Yes.
So the box is going up 1, 2, 3, 4. 4.6. Yes? And then
Yes.
this guy is going down. 1, 2, 3, 4, 4.6. Okay? And then I can finish drawing this box by this guy here. By drawing a line here and drawing a line here. And then that is the box. Okay? So far, so good.
Yes.
And that is your, what's the name for this 2 point? And the point of what?
Conjugate axis.
Yes, this is an point of conjugate axis. This is the vertices, or you say vertices through the major direction or transverse direction. This is major direction, transverse direction vertices. This is the endpoints of the conjugate axis. So you will starting from this center, -2, -4, and then you will plus the y by square root 21, minus by square root 21. Make sense?
Yes.
And how much is this guy's eccentricity? What's the C value?
5.
C is 5. Okay. Right eye. Oh, right eye is the radius. So for example, the center is for the hyperbola symmetric center. The center is not for the curves center. Your center is means the foci location. So your foci is here and here. Your curve or your loci, this is your curve, is called your loci. From any point on this curve, you draw through here. This is a radius. This is the radius. And you say, why you don't call this one radius? Well, you have 2 centers. So this is also your radius. You have 2 radius, so you call it right eye. Okay? Like you have focus. You have 2 focus, you call it foci. Okay? So that means this, if you have the C value, by the way, how much is your C? What's the C?
5.
C squared equals 25. So C is 5. So let's locate the 2 locations for the foci. Start from here. 1, 2, 3, 4, 5. Right here. Yes?
Yes.
1, 2, 3, 4, 5. Right here. That's your foci. And from this center point, go left. 1, 2, 3, 4, 5. So this is your 2 foci location. Okay? And that is called right eye. These 2 guys difference is called a foci right eye. Foci right eye for hyperbola equals to A. So far, so good? And
Yes.
then eccentricity is C over A. C is 5, A is 2. That's it. Foci, we already get the 2 foci location. Now we can get the asymptote. How much is this?
Square root 21.
Yes. So the center is at what? -2. 4, -4, right?
Yes.
So you will have y minus -4, yes? Right? y
Yes.
minus y. And then equals to, you see plus minus who?
Root 21.
Over
4.
no 2. A is 2. A is 2, right?
Yes.
Yeah. Square root 21 over 2, right? That's the slope, correct?
Yes.
And then x minus -2. Yes?
Yes.
Does that make sense? Correct?
Yes.
That's your asymptote. That's your asymptote. Okay? That is asymptote. Make sense now?
Yes.
Next. We will see one example in the vertical direction. When you have the y term as positive, this is the vertical direction. So from this given equation, this time they don't need you to do the completion square, which is good for you. So you do this guy, that's an A. Wait, hold on. Haley. With this, who is A? Who is A? A is 2, right?
Yes.
B is? B is this guy, right? 18 square root, which is 3 times square root 2. Make sense? And then C, how do you get C?
C A squared plus B squared. So 4 plus
22. So square root 22, right? Okay. And then vertices. So you start from the center. You're centered at, tell me, who is this guy's center?
1 and -2.
Yes, 1 comma -2. So you form the 1 comma -2. You will, how do you get your vertices?
To the right and left by the A.
So you will say, okay, I'm going to start from the center 1 comma -2. And I go left by 2, right? Go left by 2 becomes -1, right? And then go right by 2, which becomes 3, right? That makes sense?
Yes.
So in that way, you get your vertices. Hey, hold on. It's y direction. Sorry. We are going to move down, up in the y direction. Yes? So this guy going up become -2 plus 2 is 0, right?
Yes.
And then -2 minus 2 is -4, correct?
Yes.
So in that way, we will have 1 comma 0, 1 comma -4. That's the 2 vertices. And then we want to draw the box. So we want to get this horizontal direction by making that -1 or +1. So the center is still at 1 comma -2, but this time you will do be positive 3 times square 2 plus 1. Negative 3 times square 2 plus 1, comma -2. Okay, so you have these two locations. After you have this box, you will be easily draw this asymptote line. And then let's go ahead. How do we get this slant asymptote equation? Go ahead. Y minus who? This guy, y value is?
-2.
-2. Y minus -2 equals to the slope. So this is how much?
3 square root 2.
This is 2, right?
Yes.
And then the B direction is this, right? 3 times square root 2, right?
Yes.
So y minus -2 equals to this guy, the 2 is in this major direction, but the minor direction is 3 times square root 2. Okay? And then times x minus 0. And you put a plus minus in front. That makes sense?
Yes.
And then 2 over square root 2 will be a square root 2. Okay? So 2 over square root 2 will be square root 2. You have a 3 on the bottom. So you have y plus 2 equals to this. That's it. Okay? Yeah, this is all about hyperbola. We introduced from the starting definition how this equation come from. Then we introduce the major direction vertices and the conjugate endpoints, and also the foci locations and the asymptote equations and how to draw it also. Okay. I know many students missed today's class, and some students also missed last week and the last week class. So next Thursday, same class time, I will offer a free tutorials. All of the students are welcome to join the tutorial to help you prepare for your final. So I will not give you extra time for today, but everybody can join next week and I can answer your questions. So that's for today's class. See you next time. Today is the 14 weeks class, which is the last class. So next week is an extra free tutorial.